Okay, this one is just an example from section 3.3, and this is OpenStax Calculus, Volume 1. And what we're doing here is we're going to find a tangent line. There are many, many examples and problems in this chapter on finding the equation of the tangent line. So we sort of get the idea. It's an important theme in calculus. In this problem here, we have a function where we need to use the chain rule. Okay, what do I mean by we need to use the chain rule? Well, when we find the tangent line, the first step is we need to find a derivative. Okay, so let me read the directions. Find the equation of a tangent line to the graph h of x equals 1 over parentheses 3x minus 5 squared at x equals 2. We could even try to sketch the graph, but that's another issue, another problem, but that might be fun, but let's not do that right now. Okay, so what we need to do is find the derivative. The reason we're going to find the derivative is because we need to find the slope of the tangent line, but we're going to find the derivative. Now, I will begin with just writing down the function again. H of x is equal to 1 over 3x minus 5 squared. Okay, now we could, if you want, on the side of the paper, break this down into the composition. 1 over u squared. So u is that inside part. And 3x minus 5. So h or y is 1 over u squared, where u is 3x minus 5. You might want to start down first by writing down what u is. See what's inside the parentheses. So that might be what the u is. And then if I want to take the derivative of 1 over u squared, I should write that as y equals u to the minus 2 power, because I'm going to use the power rule. Now, I don't know if I could continue on this side work, but I don't think I'm going to do that. I'm just going to go ahead and write this down as 3x minus 5 to the minus 2 power. And I'm hoping that by writing what I did on the right-hand side, this little aside here, I'm hoping that could have maybe helped us clarify to see that this is a composition of functions, and that what we're going to do is we're using the chain rule. Okay, so we have this outside function, which is u to the minus 2 power. And when I take the derivative, I use the power rule. So this power, negative 2, comes to the front. And then I take the power negative 2 and I subtract 1. And now I get minus 3. Okay, so that's the power rule. Okay, maybe I should different color for that power. So that minus 2 goes to the front, and then I take minus 2 and subtract 1, I get my negative 3. But what I do, though, is during that time, I ignore the u part. I don't think about that when I'm taking the derivative of that outside function. And then I copy it back down and put it inside that derivative. Now, I follow up by taking the derivative of what's inside. And that's, really informal, my language calling it the inside, but 3x minus 5, the derivative is 3. Okay, so I get h prime of x equals negative 2 times 3, which is negative 6. And then I want to write this 3x minus 5 to the negative 3rd power as a polynomial in the denominator. So I brought it to the denominator. I don't know, I just thought it looks better that way, but okay, so we got that. Now let's go to finding the slope. Now to find the slope, what I do is I'm going to put in x equals 2. Well, where's x equal 2 coming from? Let's see if this is going to make a mess of this work. If I put like little snail tracks from this x equals 2. That's where x equals 2 is coming from. Okay, so it's we're trying to find the tangent line at a point. I mean, roughly speaking, really roughly speaking, the graph looks like what I'm going to draw over here. It's a translation, essentially a shift and a stretch of 1 over x squared. And you can just figure it out. If you set 3x minus 5 equals 0, you're going to get that the function is undefined and therefore has a vertical asymptote at 5/3, which is, it's going to look something like this. But it's also been stretched out. Anyway, that's a whole other thing that might be frustrating because you're thinking, where'd this come from, maybe? But it's 1 over x squared, and I mean that's true. But there's a change, there's a shift and a change in a scale, and we're finding the tangent line when x is 2. Okay, we're going to find that tangent line. I haven't found the y value, but anyway. Okay, that's what we're doing. We're finding the tangent line. So the reason I just wanted to sketch the graph is just to point out that the tangent line will be different depending on, where we're finding the tangent line. I mean, it'll be a different line and especially have a different slope. So I'm going to find the slope at the point of tangency, I call it, when x is 2. So I just put in, I put this 2 into h prime. That's why we find the derivative. The derivative gives the slope, but I need to plug in. I need to plug in 2, because this is obviously not the slope. This -6 over 3x minus 5 cubed, that's not the slope. I need to have a number, and that's how I get the numbers. I put in the value for x. So this is -6. So I'm not saying my drawing is perfect. It obviously isn't, because my tangent line needed to be. See, what my picture isn't showing is enough stretching out of this graph. But it was a really rough sketch. Okay, anyway, something like that. Okay, so continuing. I need to move this out of the way. All right, so we got the slope. And then the next thing we're going to do is we're going to find the point. We already have the point x1 equals 2. y1 is found by putting 2 into h. I put f, but I mean h. Okay, so I need to put in h or 2 into h. And so I have 1 over 3 times 2 minus 5 squared. So this is going to be 1 over 3 times 2 is 6 minus 5 is 1 squared. And we already did that calculation. So I have y1 is equal to 1. And then for our line, we have, let's change up the color so it sticks out more, pops out more. So for our line, I use the point slope formula. Y minus y1 equals m x minus x1. Okay, so that's sort of standard stuff, and we know that. So we have y minus 1 equals -6 x minus 2. So I'm putting in these values that I found for the slope for y1 and for x1. Just put all those in there. So I get y minus 1 equals -6x plus 12. So y equals -6x plus 13. I think it's believable. It's definitely believable that the slope is decreasing. Oh, by the way, I wanted to let me point out that this graph is not perfect at all. Actually, it's not that bad. If I just move this over, it really would be surprisingly decent. Okay. All right, so there we did this. Okay, this is the same as a bunch of other problems that we've gone over. We've gone over so many problems where we found the tangent line. What was different about this one is we had to use the chain rule to find the derivative. And I'm, I'm just looking over this and concerned that I made a mistake, but I think that's okay. So especially it's common, not just for me, but for a lot of people to make a mistake at the very end. Okay, any comments? Like, did you see something different? Got some? This is just an example in the book. You can look up, see the solution written out in the book. So let me at least label the x and y axis here. But do you see, all we did is we found the tangent line at a point, and the slope of the tangent line is that's the big piece in calculus. That's where calculus comes in. To find the slope of the tangent line, we need to find the derivative. And we have a formula for derivative by finding h prime of x. But then to actually find the slope, we have to put in 2. And we got -6 apparently. And then we plug it into the equation of a line that we learned hopefully in